Hi everyone, welcome to this video on log laws and just logarithms in general. So another way of writing 5 to the power of 2 equals 25 is log base 5 of 25 equals 2. So what we're really saying is that this number here to this power here equals this number. Logarithms and exponentials are inverse functions, so they're kind of like opposite operations. They will undo each other, which is really nice when it comes to solving equations. So let's look at how we can use these to evaluate some problems, okay? Log base 8 of 512. So what that means, as I said up here, is we're saying this number here to this power here equals this number. So that means 8 to the power of something equals 512. 8 to the power of something equals 512. That's another way of thinking of this. And so if you know your perfect cubes, you know that's going to be 3. So the second one, log base 3 of 1 on 27. So in a similar way, this means 3 to the power of something equals 1 on 27. We've seen this one a few times before already, so that's going to be negative 3. In the third one, 2 to the power of something equals square root of 2. Now, might be able to recognize this from the index law, but square root of 2 is the same as 2 to the power of half. So that means the answer here is half. We have log laws just like we have index laws, and you'll see here that these are more or less the opposite of the index laws. So the first one, we have log A of m plus log A of n. We're adding these here, so what we're going to do to simplify it is we take log base A of mn. The two things that are inside the log function get multiplied. It's important to note here that firstly, the logs must have the same base. They should also not have any kind of number in front of them or anything like that to be able to do this process. And also that this A here is written as a subscript. So it's really important to sort of write it that way rather than writing log A of n, because, well, that's just Logan, okay? So that's bad, don't do that. Now, the second log law, so we have log A of m minus log A of n. So you might have guessed already that this is going to be log A of m over n. So when we are minusing logs, we divide what's inside the log function. Log A of 1, well, this is just like the first questions we were doing. This means A to the power of something equals 1. That something must be 0. These last two aren't as logical, okay? Or perhaps they are, but I'm not going to go into explaining why they work the way they do in this video. But log A of m to the power of p, what we can actually do is we can move the power out the front. And so we have log amp equals plogam. And so using that same law, the fifth log law means we can move that minus 1 out the front, and so we get negative log A of m. Okay, so 5 different log laws which really are quite similar to the index laws. Hopefully that makes them a little bit easier to remember. So if we have a look at this question here, simplify 2 log 10 of 3 plus log 10 of 16 minus 2 log 10 of 6 on 5. So first thing I want to do is I want to make it so that there are not any numbers out the front of these. So using the fourth index law, I'm going to move the number from out the front into the power. So that is log base 10 of 3 squared plus log base 10 of 16 minus log base 10 of 6 on 5 squared. Simplifying that gives log base 10 of 9 plus log base 10 of 16 minus log base 10 of 36 on 25. Now I'm going to use the first and second laws. So that is, when I add logs, I multiply. When I subtract logs, I divide. So this is going to become log base 10 of 9 times 16 divided by 36 on 25. a number divided by a fraction. So the number in the denominator of the denominator, so 25, can actually move right up to the top. So log base 10 of 9 times 16 times 25 divided by 36. I'm going to cancel these out now. So 9 goes into 36 4 times. 4 goes into 16 4 times. So we're left with 1 in the denominator and 4 times 25 in the numerator, which means this is log base 10 of 100. And so then we ask ourselves, well, 10 to the power of what equals 100? The answer is just 2. Pretty nice. Alright, so the last part, we're going to have a look at solving some log equations. So the first equation, if we read it the same way, says 6 to the power of 2 equals x. So therefore x must equal 36. The second one, I'm going to use the log law, the first log law, to combine them. So that is log base 5 of x plus 2 x take 2 equals 2. Now that x plus 2 x take 2, that's just difference of 2 squares. That's log base 5 of x squared minus 4 equals 2. And so what we know then is that 5 to the power of 2 equals x squared take 4. So x squared equals 29, because 25 plus 4. And then we can take the square root of both sides, so x equals plus or minus root 29. Now, we're actually going to reject the negative solution here, because we can't take the log of a negative number, it doesn't work. So that's not going to work in this second part of the equation, which is a bit problematic. And actually, well, it probably won't work in this first part here either. So therefore x is just equal to root 29. So that's the second one. And the third one, log x of 216 equals 3. So this means x to the power of 3 equals 216. And again, if you know your perfect cubes, then you'll know that x must equal 6. So there we have it. Anyway, that's your introduction to logs. I will see you next time.